Good morning dear students, welcome back. So this is the next part of the quantum mechanics video. Already in the previous video I explained about de Broglie concept and Heisenberg uncertainty principle. Here is the next question, that is question number 5. Set up one-dimensional time independent Schrodinger wave equation. See dear students, normally we have a equation for progressive wave. Any wave which is propagating in a particular direction, it will be represented by a second order differential equation. Either it is a sound wave or light wave or any wave. It will have a variable, that is variable is a function of position and time. So y is equal to f of xt. Similarly in matter wave also we have a variable psi, that is a function of x and t. So Schrodinger attempted to set up a wave equation in terms of wave psi, that is wave function. So that equation, either it may contain time parameter or may not also. If time parameter is there, it is called time dependent equation, otherwise it is called as time independent equation. And wave can travel along x axis, y axis, z axis. If you consider any one of these axes, then it is called one dimensional. Suppose if you consider all the three directions, then it is three dimensional wave equation. But for as per the syllabus, we have only one dimensional wave equation. So the wordings goes like this: a progressive wave, that's what I told you, a progressive wave along x-axis can be represented by second order differential equation. So d square y by dx square equals 1 by v square into d square y by dt square. Look at this, y is variable with x, y is variable with t also. That's why we have d square y by dx square, d square y by dt square, and v is velocity. Similarly, in the place of y, if you put psi, then it is going to become differential equation for matter wave. So matter wave can be written as d square psi by dx square is equal to 1 by v square into d square psi by dt square. Now comes the next one. Well, for any second order differential equation, there will be some solutions. Okay, there will be solutions, and here solution, there are many procedures in mathematics. I will not take all these steps into account. I directly write the solution. Solution is psi is equal to a into e to the power of I into kx minus omega t, where a is constant, I is imaginary, k we already know it is nothing but 2 pi by lambda, omega is equal to 2 pi f or 2 pi nu. Now differentiate this with respect to t, because I want to remove this t, because I want time independent wave equation. Therefore I would like to find d square psi by dt square. So when you differentiate this equation once, you will get this a e to the power of something is same only, a into e to the power of that into minus I omega. I don't think it is very difficult for you. These are all very basics of differentiation. Well, once again when you differentiate this, that is d square psi by dt square, ಎರಡು ಸತಿ differentiate ಮಾಡಿದಾಗ a as it is ಇರುತ್ತೆ. This once again e to the power of something into, I am differentiating with respect to t alva, therefore it is minus I omega once again. Earlier I had minus I omega, that is coefficient of t. Now again minus I omega, therefore it is minus I omega whole square. Well, now look at this parameter. This parameter is nothing but psi only. Therefore this whole thing I write as a psi. Next, minus square is plus, no doubt. But I square is once again minus only, because you know I is nothing but root of minus 1. So root of minus 1 whole square is minus 1. So root of minus 1 whole square is minus 1 only. That's why I have minus omega square. So this whole thing is psi, and minus I omega whole square is minus omega square psi. Well, so I have this with me, then I substitute this in the equation 1. So when I substitute for d square psi by dt square, it becomes minus omega square psi. But ಇಲ್ಲಿ 1 by v square ಇತ್ತು. Earlier there was v square. So v is already known, it is omega by k, therefore omega by k whole square. Okay, omega square cancel, k goes to numerator, therefore it is k square psi minus k square psi. Okay sir, what is k? We know k is nothing but 2 pi by lambda. K is nothing but 2 pi divided by lambda, therefore k square is 4 pi square by lambda square. So therefore this is 4 pi square by lambda square with negative sign. Okay, next proceed. See, the previous equation I have written once again. Just erase this unwanted thing. Well, so d square psi by dx square is equal to minus 4 pi square by lambda square was there. No, I have taken that 1 by lambda square separately. Lambda square was in the denominator. I write it as 1 by lambda square. Why? Because I am going to replace that 1 by lambda square. Now we know total energy is always equal to kinetic energy plus potential energy. Okay, therefore kinetic energy is equal to total energy minus potential energy. So kinetic energy is equal to total energy minus potential energy. Total energy I take it as E, potential energy I take it as V. In some colleges they take it as U minus V. U is total energy. Anyway, symbol hardly matters if you know their meaning, but you have to define where E equals total energy, V equals potential energy, like that you have to mention. Okay. Now, in the previous video, I had given this formula, lambda is equal to h by root of 2m into Ke. Ke is kinetic energy. So, lambda square is h square divided by 2m into Ke. So, square root will go off. So, lambda square is equal to h square by 2m into, in the place of kinetic energy, I can write E minus V, that is E minus V. Okay, now lambda square is available with me. Just to take the reciprocal, 1 by lambda square becomes 2m by h square. So why we have to take the reciprocal? Very simple. I have 1 by lambda square here. That is why ashtene beri nenu, there is no special in this. Well, 1 by lambda square is equal to 2m by h square. This E minus V goes to numerator. Okay, I have equation 3. Substitute 3 in 2. Substitute 3 in 2. So take this whole thing in this equation. Then d square psi by dx square as it is equal to minus 4 pi square psi as it is. In the place of 1 by lambda square, I have 2m by h square into E minus V. Okay, now. Well, rearrange. 4 into 2, 8. So take it this side, it becomes 8 pi square m. So I write 8 pi square by m h square into E minus V. Finally, I write psi. See, it doesn't make any difference. Rearrange them according to your requirement, so that it will look like an equation which is having variable psi anta ashtene. So psi anna illi bardange, illi konege bardidini, that's all. So this is d square psi by dx square plus 8 pi square m by h square into E minus V psi equal to 0. This is the Schrodinger wave equation in one dimension. So one dimensional equation bantu. ಕೆಲವೊಮ್ಮೆ 3 dimension just mention ಮಾಡಿ ಅಂತಾರೆ. For 3 dimension you write del square psi plus 8 pi square m by h square E minus V into psi equal to 0. This is 3-dimensional Schrodinger wave equation. Okay, with this I move on to the next question. Well, next question is, well, let me see what is the next question. Discuss the characteristics of wave function. Wave function properties ಏನು? Born's approximation and normalization of wave function. See, these are all very small things, but very important things. You can expect them for 3 marks, each for 3 marks, so that it will be 9 marks question. Sometimes they can ask even for 2 marks and 6 mark question also. Well, first of all, properties. What are the characteristics of wave function? Dear students, we know psi is a probability of finding the particle. Therefore, it must have only one value at any instant of time. For example, if I try to locate you in particular place in our college, let us say college canteen, if you are not there, means not there, probability is 0. If you are there, it is 100%. I cannot say probability of finding you in canteen right now is both 0% and 100%. That is not possible. If it is the case, what does it mean? You are right now there in the canteen and not there in the canteen. Does it carry any meaning? No. Therefore, what we can say, psi is single value, and it should have continuous values also, no breakup at all. Okay, psi is therefore continuous and a single value, the first property. Next, when you differentiate the wave function with respect to position or with respect to time, that also should be continuous. Okay, like for example, this pen is going from here to here. So you are looking at the pen, everywhere the position of the pen is located. Suppose here the pen is missing, that means there is a discontinuity. If pen cannot miss somewhere here, it cannot go missing all of a sudden. Okay, so it is not a magic. As long as it is moving along x-axis, definitely the pen will be visible. By chance pen is moving along y-axis. Now you cannot see the pen. Okay, it is moving in space and suddenly reappeared and going like this. In that case, pen is moving not only along x-axis, also along y-axis. In that case, okay, then there will be continuity along y-axis. See, any axis you take, when you differentiate, it should have continuous values. Maybe small value, maybe bigger value, but it should have some value. It cannot have zero value as long as it is moving along particular direction, particular axis. That is the meaning of second property. Of course, third one, psi must be normalized. I tell you what is normalization, and it cannot be infinity. See, probability becoming infinity does not carry any meaning. Like let us say Raghu is a student. Raghu, probability of finding Raghu in canteen is infinity, meaningless. Probability of finding Raghu in canteen is 100% means yes, Raghu is there. Probability finding Raghu in canteen is 0%, yes, Raghu is not there. Probability of finding Raghu in canteen 20% means I tried 20 times, I tried 100 times, he was there only 20 times. Okay, when I try to locate his position in canteen, okay, from 10 to 11, I could see him only 20 times in the canteen, not 100 times. Like that it varies. I cannot say probability is infinity. So probability becoming infinity, meaningless. That is the third property. So these are the properties of wave functions. Dear students, all these things are available in my notes. Please download the notes using the link given in description box. Next, see, probability is wave function is a probability of finding the particle. Probability cannot be imaginary. Probability cannot be, negative. It is always real and positive. But just look at the Schrodinger wave equation derivation. I wrote psi is equal to e to the power of. I just write the solution. Psi is equal to, I wrote one solution. Psi is equal to a into e to the power of I into kx minus omega t. See, what is this I? It is imaginary. Once I am telling probability cannot be imaginary, but in the equation I am taking probability imaginary. Which one is correct? So for avoiding this, Max Born gave the following explanation, and that is called Born's approximation. What he says, see, in case of normal waves, just 1 minute, in case of normal waves, okay, I write one normal wave diagram. See, this is a normal wave where this part is called amplitude and this is also amplitude, but here it is negative amplitude, this is positive amplitude, and if you take the square of amplitude you get intensity. Intensity is also called as radiation density. So in case of normal wave, we don't give much importance to amplitude, but we give importance to intensity. By taking square of amplitude, we get intensity. So therefore, and intensity is always positive. Because intensity is always positive, we give more importance, we care for intensity. On the same grounds, Born says, the wave function represents probability of finding the particle, no doubt, at a given instant of x and t. It cannot be negative and imaginary, that's what I told you. But probability, cannot be negative. Negatives do not have any meaning, it is meaningless. In order to overcome this problem, the problem of imaginary, Max Born gave some explanation which we call as Born's approximation. What he says, background, wave function imaginary ಇರಬಾರದು, ಆಮೇಲೆ ವೇವ್ ಫಂಕ್ಷನ್ ಅಲ್ಲ, ಪ್ರಾಬಬಿಲಿಟಿ ಇಮ್ಯಾಜಿನರಿ ಇರಬಾರ್ದು ಮತ್ತೆ ನೆಗೆಟಿವ್ ಇರಬಾರ್ದು. ಆದ್ರೆ ವೇವ್ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ಇಮ್ಯಾಜಿನರಿನೂ ಇದೆ, ನೆಗೆಟಿವ್ ಇದೆ. ಅದನ್ನು ಓವರ್ಕಮ್ ಮಾಡಲಿಕ್ಕೆ ಬಾರ್ನ್ ಏನೋ ಒಂದು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಕೊಡ್ತಾನೆ. ದಟ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ವಿ ಕಾಲ್ ಆಸ್ ಬಾರ್ನ್ಸ್ ಅಪ್ರಾಕ್ಸಿಮೇಷನ್. ಏನ್ ಹೇಳ್ತಾನೆ ಅವನು? ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಫೈಂಡಿಂಗ್ ಎ ಪಾರ್ಟಿಕಲ್ described by the wave function psi at any point x and t is proportional to a parameter called probability density, that is modulus of psi square at x comma t. Okay, so even if psi is imaginary and negative, modulus of psi square is always positive. Why? Because when you multiply psi by its complex conjugate psi star, imaginary becomes real. Okay, and when you take modulus, negative also becomes positive. Therefore, he says a probability density is more significant than probability alone. ಹಾಗೆ intensity is more significant than amplitude alone ಅಂತ ಹೇಳ್ತೀವೋ ಹಾಗೆ ಬಾರ್ನ್ ಪ್ರಕಾರ ವೇವ್ ಮ್ಯಾಟರ್ ವೇವ್ಸ್ ಅಲ್ಲಿ ಪ್ರಾಬಬಿಲಿಟಿಗಿಂತ ಪ್ರಾಬಬಿಲಿಟಿ ಡೆನ್ಸಿಟಿಗೆ ಬಹಳ ಪ್ರಾಮುಖ್ಯತೆ ಇದೆ. ಪ್ರಾಬಬಿಲಿಟಿ ಡೆನ್ಸಿಟಿ is more significant than probability alone. So it is obtained by multiplying wave function by complex conjugate. So probability density, that is modulus of psi square, is equal to psi star. This is Born's approximation. And coming to concept of normalization. See, when you plot a graph of wave modulus of psi square versus x, you will get a positive wave only. Now there is no question of negative wave. Now at any position, at any point, if you want to find the probability, then you will have to calculate the area. Look at this yellow shaded region. This region tells you the probability of finding the particle. The area of this region is length, that is dx, into height, that is psi square. So psi square into dx gives you the probability. Like that, if you want to find the probability from here to here, then you have to find area from this 0 to x. The total area is nothing but integral of psi square dx. Okay, that's what a probability of finding the particle is calculated by calculating area under the curve psi square versus x. It is done by multiplying psi square by distance dx, shaded area. That's what I explained. ಇಲ್ಲಿ ಏನು explain ಮಾಡಿನೋ ಅಲ್ಲಿ wordings ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದೀನಿ. That is psi square dx. The total area gives the net probability, that is from this origin to this point, total area, and that must be equal to 1. So this totaling process is known as normalization. That means integral of psi square dx, totaling, sorry, the psi square must be outside the modulus. Totaling of psi square dx over the range of 0 to x is nothing but normalization. See what we do, we calculate area over here, this area, similarly this area, similarly this area, all this area, that is psi 1 square dx1, psi 2 square dx2, psi 3 square dx3, like that. So now you add all of them, etc., etc., that must be equal to 1. So that means integral of starting from this point 0 up to this point x, that is 0 to x, modulus of psi square dx is equal to 1. This is known as a normalization. So the wave function must be normalization. Okay, the wave function must be able to get normalized. If the wave function cannot be normalized, then it cannot be considered as a proper wave function. Well, you are totaling from 0 to x, it is called one-dimensional normalization. If you are totaling over area, then it is 0 to s, means surface integration. That is two-dimensional normalization. If you total it over volume, because particle not necessarily can travel along x-axis, it can travel along y-axis also, it can travel in space also. Therefore, when it comes to three-dimensional integration, it is dv, not dx. Dx means it is length, ds means it is surface area, dv means volume. So normalization in 3 dimension. And one more thing, lower limit is definite, upper limit is definite, 0 to x, 0 to s, 0 to v. Suppose if lower limit is infinite, upper limit is also infinite, then it is called normalization for free particle. Like particle is not starting from here and going up to here, it is starting from somewhere else, going to somewhere else. That means it is coming from minus infinity, going to minus infinity, means it is a totally free particle. For free particle, equation will be same only, but only thing is upper limit and lower limits are not 0 and x. This is minus infinity, this is plus infinity. This is known as normalization. Okay, I hope you are following. Coming to the next question. What are eigenfunctions and eigenvalues? Give the characteristics of wave function. See, dear students, eigenfunction definition is like this. See, whenever you do some operation on a quantity, there may be change in the quantity, there may be change in the equation, there may be change in the function, there may not be change in the function also. Let us say I have a number, this number is 4. When I do some operation like square root is the operation, definitely I will not get 4, okay, I will get it as 2, okay, 2. Similarly, let me take sin theta. Sin theta is a function. When I do some operation, say differentiation of sin theta, definitely will not give sin theta, it gives cos theta. Suppose if I have a cos of 3 theta, when I differentiate this, differentiation is operation, I get minus 3 sin theta. Okay, nodi 4 is not 4, sin theta is not sin theta, cos theta is not cos theta. So in these cases, operator is changing the format. Suppose if some function is not changing, like e to the power of 3x, say for example, when I differentiate this, what will happen? 3 into e to the power of 3x only. Well, I had 3 to the power of 3x, I have e to the power of 3x. Now I call e to the power of 3x as eigen function, and 3 what I get here, 3 e to the power of 3x is eigen function, and this 3 is called eigen value. With this explanation I come to the definition. Okay, nodi definition anna nodi, there are certain functions that will not change when operated upon by the operator. This operator may be square root operator, differentiation operator, integration operator, any operator. When it operates, if it is not changing the function, then the function is called eigen function. There are certain functions that will not change when operated by some operator, then these functions are called eigen functions of that operator. Well, application of an operator on each of its eigen function leads to characteristic number. ಇಲ್ಲಿ ಬಂತು ನೋಡಿ, e to the power of 3x ಮೇಲೆ ನಾನು ಅಪ್ಲೈ ಮಾಡಿದಾಗ I got characteristic number 3, and that number is eigen value. I give you one more example. For say I have sin 3x. I differentiate this twice, d square by dx square, that is equal to what? Can you think? When you differentiate first, it will be 3 into sin 3x. When I differentiate it once again, I get 3 into differentiation of sin is cos 3x. When I differentiate it once again, I get 3 into minus 3x. Please try this. That is equal to minus 9 into sin 3x. See, I had 3x once again, I got 3x once again, but I got a number minus 9. This minus 9 is eigen value, and then this sin 3x is eigen function. So application, that's what the statement is. Application of an operator on each of the eigen function leads to characteristic number which is real number, and it is called eigen value. Of course, minus 9 is real number, 3 is a real number, so the value what you get is eigen value. This is general definition, but that's what I have mentioned here. O is an operator, f of x is a function. If you get back same f of x, then it is eigen function. Along with that, I have a here, a is eigen value. This is what is called eigen function, eigen value general definition. But for a wave function to become eigen function, it has to satisfy these properties. In order to become wave function, it has to satisfy the properties of wave function. Wave function becoming eigen function, wave function becoming proper function, it must possess following properties, which I already mentioned in my previous video. Previous question. Well, this is about eigen values, eigen functions, Born's approximation, Schrodinger wave equation, etc., etc. Well, with this I stop this video. It is becoming lengthy. Now I have what is called particle in one-dimensional box, applications of Schrodinger wave equation to particle in one-dimensional box. That I will take as a separate video. Okay, and with that I conclude this module, and then I take up the third module, lasers and optical fibers. Please watch my video, subscribe to my channel, also share your comments. Okay, thank you very much.